Okay, Chapter 1, Lesson 8, Interpreting Graphs of Functions. So today we're going to be looking at graphs of functions, and we're going to be looking for a couple different things. The first thing we're going to do is be able to identify the x and y intercepts. So the x-intercept or intercepts is the points where the graph crosses the x-axis. And then the y-intercept are the points where the graph crosses the y-axis. Now, anytime we have an x-intercept, because it's the x is the number and it's on the axis, it's going to be a number, comma, 0. And for the y-intercepts, because it's on the x-axis or on the y-axis and it's a y number, it's going to be 0, comma, a number. A graph is linear if it forms a straight line, and nonlinear if it has any sort of curve to it. So here's the first thing. Determine if the following are linear or nonlinear, and then give the approximate intercepts. So first of all, looking at this wholesale t-shirt order, looks to me like it's a straight line, so I'm going to call it linear. And it wants me to see if it has any intercepts, any points it crosses the x or y axis. Well, I see here an intercept, and it's a y-intercept because it's crossing the y-axis. And if I had to guess looking at the numbers here, since this is 200 and this is 400, that would make this 100. And I'll erase this so we can kind of see. Looks to me like it crosses about 50 on the y. And so since it's a y-intercept, it's going to be 0, comma, 50. And I do not see an x-intercept. Number 2, I see this has a slight curve to it, so I'm going to call this non-linear to start. And once again, I do not see an x-intercept. I do, however, see this y-intercept up here. And counting, it goes 36. This would be 38, 40, 42, and it's kind of just above it. So I'm going to call it a y-intercept of 0, comma, 43. This one again has a curve to it, and so it's non-linear. I see both an x-intercept this time and a y-intercept. The x-intercept, this is 1. This would be 1.25, 1.5, 1.75. Since it's the x, it goes first and then comma 0. For my y-intercept, it looks like right at 10, and it's the y, so it goes in the y spot, and the x gets the 0. I can determine if a line has symmetry. So what is symmetry? Symmetry is when you can fold the line in half, and the left half would look like the right half. So this question asks, do any of the following lines have lines of symmetry? Number 1, I would say yes, because I could fold the line right here and then take this end and fold it over on this end, and I think they would match exactly. So I'm going to say yes, this has symmetry. On the second one, if I folded it right here over this line, I think that those would match. It'd be pretty close. So I'm going to say yes, this one also has symmetry. And this one I would say no, because no matter where I try to fold it, because this is such a big curve and this is pretty flat, I don't think anything would match this curve. And so I'm going to say no, it does not have symmetry. Next thing, determine where a function is positive, negative, increasing, and decreasing. So a function is positive when it is in quadrant 1. So remember our quadrants from last week: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So I would think a function would be positive as long as it's up here in this quadrant. My function is negative when It is in quadrants 2, 3, and 4. Because if it was over here, my thing right here, it would still have a negative x value. Down here, it would have negative x and negative y. And this one would be a positive x, however, still a negative y. A function is increasing when it goes up from left to right. And a function is decreasing when it goes down from left to right. So an example of this one, it'd be increasing anytime it goes up from left to right and decreasing anytime it goes down from left to right. Estimate and interpret where the function is positive, where it is negative, where it is increasing, and where it is decreasing. So if I look kind of here, I think this would kind of be my axes, my origin right here, 0, 0. So in this one, I would label this part of my graph as positive and this half of my graph as negative. It also wants me to tell where my graph is increasing and where it is decreasing. So anytime my graph is going down from left to right, like in this point right here, I would call that decreasing. I'm just going to put a negative is fine. On this one, it's still going down. So I would say here it is also decreasing. In this part right here, it is going up, so it's increasing. And this part, it's flat, so that would be constant. On number 2, I notice this is all in quadrant 1, as these are my axes and there's 0, 0. So I would say this whole thing is positive. And besides maybe this little part right here, right there, maybe would be a little bit of decreasing, but this part and this part, I would say, are definitely increasing. So maybe just a little part of decreasing. I can describe the end behavior of a graph. I can find the relative minimum and relative maximum of the graph. So when it asks us to describe the end behavior of the graph, remember that we need to use titles. We're going to be using titles of the axes. And we're going to describe what we think will continue to happen based on the end of the graph. We're going to do that on the next slide, so I'm not going to give an example quite yet. Relative minimum is a guess at the lowest point of the graph, and it only happens if the graph is not linear. A relative maximum is a guess at the highest point, again, if the graph is not linear. So some graphs will have no min or max, that's when they're linear, and sometimes they could have 1 or 2 of each. So on this one, find the relative min and relative max, and then describe the end behavior. So this one is linear at the bottom, but I do notice that it stops here at that point. So since it's ending at that point, I would call that one a relative max. And it's at 0, 242-ish. I don't know, it's a little bit above 240. There is no relative min because it keeps going forever. And if I'm describing the end behavior, I can see it's continued to go down. So I would say over the years, the population of whales continues to decrease. So I'm using the years, I'm using the population, I'm using the title whales, and I'm talking about how it's going to continue to decrease at the end. On this one, I would say it has a relative min right here. And I would say it's about 3, -1.5. And I would also call this one a relative max. And that one is at 6, 0.5. And then to describe this, it looks like it's going to be constant. So I would say since opening bell, the price variation will continue to be the same. Or I could say continue to be constant. You can use either words. That's all.